If you're running SD-WAN appliances in AWS and still using VPN tunnels to connect them to Transit Gateway, you could be leaving significant bandwidth on the table and paying for performance you'll never see.
Wait, significant bandwidth? How much are we talking about here?
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm your host, and today we're diving into Transit Gateway Connect attachments with my co-host here.
Hey everyone, I've been hearing about Connect attachments, but honestly, I'm still using regular VPN connections for everything.
Perfect timing then, because this is going to change how you think about SD-WAN and AWS.
So let's start with the basics. I've got a third-party SD-WAN appliance running in a VPC, like a Cisco Catalyst or Palo Alto Prisma. Right now I'm connecting it to Transit Gateway using a Site-to-Site VPN. What's wrong with that approach?
The fundamental problem is bandwidth efficiency. A Site-to-Site VPN connection to Transit Gateway gives you two tunnels, each maxing out at 1.25 gigabits per second. With ECMP load balancing across both tunnels, that's 2.5 gigabits per second per VPN connection. Now, you can add more VPN connections and use ECMP to scale beyond that, but you're adding complexity with each connection. Meanwhile, your SD-WAN appliance sitting on a C5N instance could push 25, 50, even 100 gigabits per second depending on the instance type.
So I'm paying for a high-performance instance, but the VPN tunnels are the bottleneck, and scaling means managing multiple connections?
Exactly. It's like buying a Ferrari but only being allowed to drive it in a school zone. Transit Gateway Connect attachments solve this more elegantly by using GRE tunnels over a dedicated transport attachment, giving you up to 20 gigabits per second per Connect attachment with support for multiple Connect peers. That's up to 4 times the bandwidth density compared to a single VPN connection, with a simpler architecture.
Okay, GRE tunnels. I know GRE is generic routing encapsulation, but how is that different from IPsec VPN?
Great question. Think of it like shipping packages. IPsec VPN is like putting your package in a locked safe, then putting that safe in a shipping box, then having someone verify the contents at every checkpoint. Secure, but slow. GRE is like putting your package directly in a shipping box with just a label. Much faster because there's no encryption overhead, but you need to trust the delivery route.
But wait, doesn't that mean my traffic is unencrypted? That sounds like a security problem.
Here's the key insight. The GRE tunnel in a Connect attachment runs over a VPC attachment or Direct Connect attachment, which is your transport attachment. That traffic never touches the public internet. It stays within AWS's private network fabric. So you're trading encryption for speed, but you're doing it in an environment where encryption isn't strictly necessary because the transport is already isolated.
That makes sense. So the GRE tunnel is like a private highway that only exists inside AWS's network. No one else can access it anyway.
Exactly right. Now here's where it gets interesting for SD-WAN. Connect attachments support BGP, specifically MP-BGP with support for both IPv4 and IPv6 address families. Your SD-WAN appliance can dynamically advertise routes to Transit Gateway using BGP over the GRE tunnel. This is huge because SD-WAN solutions like Cisco SD-WAN, VMware SD-WAN, or Aruba Edge Connect all speak BGP natively.
So instead of manually configuring static routes or dealing with VPN route propagation limits, my SD-WAN controller can just advertise routes dynamically?
Yes, and this is where the architecture gets elegant. You create a Connect attachment on your Transit Gateway, associate it with a transport attachment, which is your existing VPC attachment where the SD-WAN appliance lives. Then you create Connect peers, up to 4 per Connect attachment, each establishing a GRE tunnel and BGP peering session with your appliance.
4 peers per attachment. Is that for redundancy?
Redundancy and bandwidth. Each Connect peer supports up to 5 gigabits per second, so 4 peers gives you that 20 gigabits per second maximum. AWS recommends configuring at least 2 peers for high availability, ideally pointing to appliances in different availability zones. The BGP sessions use private ASNs on the AWS side. You can use 16-bit private ASNs in the 64,512 to 65,534 range, or if you need more flexibility, 32-bit private ASNs from 4,200,000,000 to 4,294,967,294. The default is 64,512 if you don't specify one. You configure your appliance with its own private ASN.
Let me make sure I understand the architecture. I have my SD-WAN appliance in a VPC. That VPC has a regular VPC attachment to Transit Gateway. Then I create a Connect attachment that uses that VPC attachment as its transport. And the connect peers are the actual GRE plus BGP sessions between Transit Gateway and my appliance.
Perfect summary. The VPC attachment is the foundation, the connect attachment is the framework, and the connect peers are the actual tunnels carrying your traffic and routing information.
What about the IP addressing? How do the GRE tunnel endpoints get configured?
This is where people often get confused. When you create each connect peer, you specify a /29 CIDR block for the inside IP addresses of the GRE tunnel. You have two options here. You can use addresses from the 169.254.0.0 out of 16 link local range, but be aware that AWS reserves certain blocks you can't use, like 169.254.0.0 out of 29 through 169.254.5.0 out of 29 and 169.254.169.248 out of 29. Alternatively, you can use any valid internal IPv4 CIDR from RFC 1918 space. For example, 169.254.100.0 out of 29 or 10.255.0.0 out of 29 would both work. This gives you addresses for both the transit gateway side and your appliance side of the tunnel.
And the BGP peering happens over these inside addresses?
Exactly. Your appliance establishes a BGP session with Transit Gateway using these tunnel interface addresses. You'll configure something like neighbor 169.254.100.1 remote as 64,512 on your appliance, where that IP is the Transit Gateway's tunnel endpoint.
What's the biggest mistake you see people make with connect attachments?
Two things. First, not thinking about network reachability and aws placement. Your appliance needs to be able to route to the Transit Gateway attachment any to establish the GRE tunnel. AWS recommends placing your appliances in the same availability zones where your Transit Gateway attachment subnets exist. This isn't strictly required for the tunnel to work, but it optimizes latency and helps you avoid cross-aws data transfer charges. Second, not configuring BFD, bidirectional forwarding detection. Transit Gateway Connect supports BFD for fast failover detection. AWS sets the BFD parameters on their side at 300 milliseconds interval with a multiplier of 3, giving you roughly 900 milliseconds detection time. You can't change these values on the AWS side, but you need to configure your appliance to match.
900 milliseconds versus waiting for BGP hold-down timers to expire. That's still a massive difference for production traffic.
Absolutely. Without BFD, you could wait 90 seconds or more to detect a failure. Always enable BFD on your sd-wan appliance's BGP configuration. The configuration varies by vendor, but for Cisco you'll need two parts. First, enable BFD on the tunnel interface with something like BFD interval 300 minutes _RX 300 multiplier 3. Then enable BFD for the BGP neighbor with neighbor 169.254.100.1 fall over BFD.
Let me recap what I learned. Connect attachments give me high bandwidth GRE tunnels instead of managing multiple VPN connections, up to 20 gigabits per second per connect attachment versus 2.5 gigabits per second per VPN connection. They use BGP for dynamic routing, which integrates naturally with SD-WAN appliances. The GRE tunnels run over existing VPC or direct connect attachments, so traffic stays private. And I need to configure BFD for fast failover, matching AWS's fixed 300 millisecond interval.
Perfect. One final pro tip. When you're designing this, check the current AWS pricing page for your region since prices change over time. Generally speaking, Connect attachments offer competitive data processing rates compared to VPN connections, and when you factor in the bandwidth density, you're getting significantly more throughput capacity per attachment. The exact savings depend on your traffic volume and region, so do the math for your specific use case. Go spin up a Connect attachment in your test environment today and see the difference.
That bandwidth efficiency alone makes this worth exploring.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel.
And share this with anyone running SD-WAN in AWS. This could save them serious complexity and headaches.
Thanks for watching the Network Ninja Cloudcast. See you in the next one.